And the other day, I gave some explanation around what you call on 14th November. We discussed about what is OLTP versus OLAP, and then we also discussed about what is SQL versus NoSQL, and what is database versus data warehouse. So those topics are pretty much important. Okay, recording is there. Okay, so I'll quickly give a brush up so that way you understand it. See, the very first topic which we are going to talk about is DynamoDB, right? DynamoDB is a NoSQL category or a non-relational category database. So nowadays, a lot of gaming applications, social networking applications, or mobile app, Internet of Things related applications. So they are all systems which requires a lot of changes, or they are mostly dynamic in nature. So based on their dynamic requirement, so we need a schema that can be modified anytime and on the fly, right? If you remember, like when you take SQL, the structured querying languages were used predominantly in the enterprise business application, where you will go and have a static schema to start with, and then you will have all the rows, columns, and then you will go and specify what kind of data it should accept, and all those things, right? So schema is something which gets defined at the beginning in the SQL database. And with not only SQL, we don't have a dynamic we don't have a static schema. Instead, we go and have it on the fly. We can just go and define it, and pretty much these are all JSON files. And in the JSON file, we are going to specify what the values in the key value format. And it's not going to be like how we are specifying in your SQL database. And SQL database also has a lot of tables which are getting linked to each other, and we have to do a lot of joins. And in order to design the complex queries, you have to join multiple tables and get the result, right? And these are all predominantly used for your online transaction processing application, like banking, or finance, or maybe online ticket booking systems. So for which, like the online transaction processing applications, SQL database is pretty much good to be used. And whereas for the online analytical processing, then I think you cannot have a rigid schema, and you definitely need something which is very flexible enough and dynamic in nature. So that's where the NoSQL databases, or the DynamoDB databases, comes into play. And from AWS, yeah, they have given you um, the key value store option. Document database is there, and then we also have a wide other variety of options. So especially for the gaming, social, web application, mobile applications, so organizations or enterprises are going for the key value store especially. And document DB is also needed for some of the applications where you want to directly store the content in the document format and utilize it. So under the not only SQL category, there are many different examples. And Amazon DynamoDB is a key value database, and it's a not only SQL or a non-relational database category. And if you want to migrate from your on premises to DynamoDB, or for example, if you have a MongoDB, or if you have some other data format, and you want to migrate, you can use DMS to get that migrated to DynamoDB. It is pretty straightforward. I can also share that step-by-step demo. So there are many different products that are offered in AWS platform for the databases. And the DynamoDB is the NoSQL, not only SQL category database offering. And this is a serverless database. It's a fully managed serverless database. As a customer, we don't have to manage the database, and it's pretty readily available, and you can go and get whatever space you need, whatever the performance expectations can be met. There are many different options. And we will also discuss about the Redshift in the second half. The first half, we will conclude the DynamoDB, and then we can go to the Redshift option. So as I told you, there are many different options other than your relational database. So relational database service is like your RDS, and within that you get Microsoft SQL, Oracle, MySQL, PostgreSQL, and so on. Even MariaDB is there. And key value database is where It is used for the applications which need very low latency, and they are also based on key based queries and with high throughput. So these are the examples, right? Any internet scale applications, online app, and real time bidding applications, the shopping cart where you are going and selecting what you need, and then have the products in the cart, right? And then any customer preferences they want to have. So all these applications are good to work with the key value databases. So especially the modern application, they are demanding such backend database for those content to be stored. So that's where all these new options are popping up. And the main important thing is these databases are fully managed, right? That is the primary important thing. And any database nowadays, customers they don't want to focus on infrastructure, they want to focus on their applications and database, right? So this is provider AWS manages the infra, right? And again, it is serverless. That's what we are start talking about as fully managed. So customer don't have to manage the patches, patching, or monitoring, or updates, or upgrades. So all these are taken care pretty much by the provider Amazon, and it is pretty much scalable. Okay, you get unlimited capacity. So for the user, it is invisible, and virtually it is unlimited capacity, and you get the best of performance, and the performance is also predictive levels. And if you're going and using DynamoDB, you also have the option to go and mention like what kind of throughput you need, and for your application specific requirement, you can achieve very low latencies, and they are guaranteeing you, and you can clearly they give you metrics to go and measure it. It is pretty much clearly available, and it is definitely durable and highly available by design. It is having multiple availability zone by default. And then if you want multiple data center also, you can also configure DR or business continuity. And there is an option called global table, which can also be multiple region for your database, I mean for your DynamoDB. And it is very flexible. Okay, if you want to make some changes, or if you want to continuously evolve, you can definitely there are a lot of new features and functionalities that Amazon is adding to their DynamoDB. I'll also give you some examples. And cost wise, yeah, it is pretty much affordable. Okay, it's not that costly compared to your on-premises traditional workload. So you can start, and it's a pay-as-you-go service model. Even if you don't have anything, or if you don't have any utilization, there is chances like you will also get nil bill. Okay, so that is also available in your so DynamoDB. So DynamoDB by design, it stores minimum of 3 copies of data for high availability and data durability. And these 3 copies, if you are selecting global table option, it is geographically distributed replicas across different regions. So as the in storage also we discussed the same thing, right? So 3 replicas or 3 copies of your data. So similarly here in DynamoDB, we don't call it as a data. Instead, we call it as a table and items. But yeah, we will come to that part. So very important thing is this is schema less, right? That's the reason customer is adopting this. They don't have to go and mention the schema at the beginning of the database design, unlike your relational databases. So in relational databases, before even you go and store your data, you have to mention like what is the table structure, and how many rows, columns, what kind of data types it should allow, what is the primary key, foreign key, what is the table first column name, and all those things, right? A lot of schema has to be well defined, and here it is dynamic. Okay, so you just go and start, and then whatever you want to add, if even if there are missing entries on particular columns or rows, it doesn't matter. Okay, so this is completely independent, non-relational, and you don't have to have any kind of data relationship like your RDS databases. In RDS databases, multiple tables will be created, and they will have joins, they will have link between each other by the way of foreign keys and primary key entries. So it's pretty much non-relational in nature. And if you want to scale your database, there is no downtime. It's like a push of a button can can help with horizontal scaling, and also if you want to increase the resources even without incurring downtime, you can get it. And there is a lot of catching features and a lot of additional features that they have provided. So there is a catching option like to store the session data or session state data, and also they are providing you SSD storage to have better performance and to achieve specific low latency requirement. Yeah, so DynamoDB is, again, the very first thing is it is fully managed. It is cloud native. Okay, you don't have to. It's a software as a service kind of thing where so it does not run anything on for your servers, or it's like it's only running on Amazon Web Services. So there is one more option that DynamoDB provides, that is mainly for the developers. So developers can get a free version of DynamoDB to just do some testing and all those things. That can be installed on a developer node, and they can do it, but it's only for the development purpose. But this is completely cloud native option. You don't have to install any server, or you don't have to install any software, or nothing has to be configured. So you just have to pay the bill based on the consumption. Even there is no capital expenditure. This is completely elastic infrastructure deployment. You just go and deploy and start with, and then the more you consume, it automatically scales in an elastic way. So okay, so I mean, you don't have to ready. I mean, if you want to use the traditional SQL queries, yeah, you can use it. But there are a lot of API options and JSON-based applications that you can develop or use. For example, a lot of software development kits are there. You can use C, C++, Go, Java, JavaScript, .NET, PHP, Python, Ruby. So there are a lot of SDKs that are available to access this. So it doesn't rely upon just SQL. So people think, like, when I say not only SQL, it's like it can also support SQL, but it is not only SQL statements. You can also use pretty much wide range of programming languages, APIs, SDKs to access this data. So since this is a key value store, okay, so you have to store the data in a key value pair. Okay, and whatever it can accommodate as large as an application real-time business requirement needs. Okay, a lot of customers have already migrated to DynamoDB for some of their microservices or specific application, which requires the document to be stored in a JSON structured format. So it is very simple. It is very scalable, though it is simple. Okay, and a lot of customers are using it. So this is mainly for the semi-structured data, right? And maybe for the unstructured also it can be used, but not for the structured category of applications. So if you have an application which needs a structured like the schema should have to be defined and all those things, then go for RDS options. But this is like more for the semi-structured data driven application, where if you want to have something from the social applications or mobile app. So like most of the mobile applications are running on DynamoDB these days. Like not just DynamoDB, a similar format of key value stores that are available in the market, and many providers have their own equivalent products to compete with, right? Be it Google or any company, they have their own product of choice. So coming back to the slide, okay, so Amazon DynamoDB is a cloud native, not only SQL. Primarily, it is a key value database. Okay, the next slide talks about the database as a service. And yeah, so here they are giving you a lot of options to access the DynamoDB, and there are latest features that has been added. So this has been added over the period. Okay, so DynamoDB started back as a development product way back in 2007, 2008, but Amazon did not release it to production because there was a lot of competition at that time with Big Table from Google and other products. But yeah, I think in 2012 only they had the first launch after 4 5 years of testing and rigorous usage. So AWS started using this product within their in-house requirement applications way back in 2008, 2009 itself, but it was made production ready for the external customers in 2012. And they started adding multiple the options like DynamoDB streams, adaptive capacity, the mandatory default encryption. So last 7 8 years it is already mandate, and you have options to have configure global tables. There is a new feature that has been added to support partyql, which is like a querying language which can be used for your DynamoDB, and infrequent access tables for cost optimization. They have added recently, a couple of years back. So there has been a lot of evolutions and new features that has been added over the period. So not all of these features are available since the beginning. So the snapshot or encryption at rest, the partyql support, so all these features has been added over the last 10 years of evolution of this particular product. And it can, the data whatever you are working on, it can be pretty much exported, integrated with your ETL requirement. If you want to extract the data and then transform it for some business analytics or some kind of intelligence, you can also send it to S3 or Glue or Kinesis, or even you can use Power BI, Tableau, or any kind of visualization tool to look what is happening. Like QuickSight also could be used, but yeah, it can be pretty much integrated with monitoring and logging tool. That is a base requirement. So database as a service. Okay, so underlying server, the database installation, the database instance creation, all these are taken care by the provider. We just have to go and start creating the table. The very first thing we go and create in DynamoDB is the table. Okay, and within that we go and create the items, and within that we go and configure the attribute. Unlike your RDS, in RDS we have to select what OS, sorry, not what database engine we need to run our database. Like we have to mention whether it is Oracle or Microsoft SQL or MS SQL, sorry, MySQL, and so on. And then after choosing the database engine, we have to select what is the first DB instance we have to create, and they will also create some default other databases like master, model, and other things, right? Based on your operating system or based on your database engine flavor, they are going to create additional databases, and they are going to give you those access to the database instance. So here, unlike that, you don't have to do any selection of engine. Like it's only one thing, right? So you don't have to really choose any specific engine or create any database instance, and then databases is not needed. Directly you can jump into creating the table. That's the first thing that you create in DynamoDB, and then table or collection of multiple items, and the items are made up of a lot of columns, which is like filled as a key value attributes. So attributes is nothing but it will have a name and a value. As I informed you at the beginning, this is a key value database. It will have a key value structure. So like you create something on your Active Directory or many different platforms, you go and create first name, last name, and then you just start providing the details in the form, and even in your identity management system. Similarly, you go and do it, right? So there are many other features and benefits that you might have to understand, and this is a very big list. Okay, so let's start with this is all something which I've already mentioned: serverless, non-relational, NoSQL, and fully managed. Of course, performance, they are providing you single digit millisecond performance latency. That is very good, right? So did I, yeah, performance is also exceptional. And when it comes to scalability, yeah, it scales automatically, and to support tables of any size, it offers limitless capacity, I would say, with consistent performance. That is what is important, and that's what we have mentioned here. And it provides you 99.39 of availability, and also it provides you the best resilience as much as possible for the global tables. It can be stored in multiple region, and so on. And of course, when you have this much of availability option, then of course the durability and fault tolerance will be very very high, and we are paying for what we are using it. So we are not going and investing in a lot of money there. So we are just paying for what we are using, and it has got a lot of integrations towards the other tools for performing the analytics from Redshift, or extracting the insight from Glue or other tools. It has very much very good easy integration with other AWS services, and it scales to zero if there is no usage. So which means it is optimizing the cost when there is not much real traffic on your system. And as I said beginning at the beginning, there is a lot of language binding you can use. There are a lot of SDKs and APIs that you can use. Almost all the popular programming languages, including the modern ones like Rust, Haskell, all these are also available. By default nowadays, the data is kept under encryption. That is the basic standard that they follow. Almost all the different industry vertical compliance standards are already achieved here. So primarily, like, it is a serverless, non-relational, no SQL, fully managed service with a pay-as-you-go pricing model. So those are the top five important benefits to start with. But on top of that, there are a lot of other aspects like security and these things. Just give me a second. Let me go to the console shortly. It is pretty much easy to create and practice, and you can also try it out. Okay. So unlike your relational database is tied to licensing, right? So there you can only do a vertical scaling. Here, horizontal scaling is pretty much supported, and you can expand to whatever number of systems you need, and to cater the need of your end systems, you can also get it. So I also talked about NoSQL. That is also indirectly they are conveying the schemaless information. Okay, so what else? So backup is pretty much supported. You get a point in time snapshot option, and you can also use on demand backup and restore. Those options are also pretty much there. Why? Okay, here it is. Okay, even the point in time you can have up to 35 days, last 35 days. Point in time recovery for default 35 days or minimum 35 days. And you can also have a on demand backup also. That is also available. Backup and restore is also there, and you can have a quick snapshot and recovery option also is available part of this. And very important thing is the global tables, which you should not forget. So it is a multi-region, and it's a multi-master. Okay, so all the systems will act as a master node. It's a multi-region, multi-master solution. So there is no master-slave kind of concept. If one of the server is available, or if one of the node is available, still the functionality will be fully readable, modifiable, and you'll have full access. There is nothing like primary to read, right, and then secondary to only read. Nothing like that. It's all multi-master solution, like your Active Directory. FSM or multi-master. So here it is multi-region and multi-master solution. You can have any one of the system. If it is available, then pretty much you can go and connect your application and start using it. So what else? It's providing low latency and the integration. So I think pretty much we have covered all the important aspects. Yeah, so we have covered. So let's also talk about a few more points here. Okay, these are all fine. Highly available, flexible use cases, predictable performance, multi-tenant, managed cloud service bound. Yeah, I think we have touched upon all the points here. Any questions so far on the points that we are talking here? See, just to I mean brief you on this point. Okay, these are the top six grouping or benefit. See, as a developer, the fundamental goal for them is to not worry about the backend data or database or infrastructure. Right? They need a system. The developers, they want to create an application API or SDK that can directly go and connect to a database system which is cloud based or fully managed. So that is what DynamoDB is offering you. And whatever the patching of the databases or installation of the databases or managing the OS, configuring the database level, clustering, all those hard work, hardware level, operating system level, software level. When I say software, I'm talking about the database application. All these are completely fully managed starting from provisioning to management to governance. So it is all completely API driven. Your application has to be written, and your app has should have the compatibility to connect to the DynamoDB. And if the developer focuses on that and creates it, then all the backend encryption, backups, failures, upgrades, updates will be fully managed by the Amazon as a, I mean, AWS database as a service offering here. And the second thing is it is a multi-tenant architecture, right? So of course, like if multiple customers are using it, then you will get a cost benefit, and that way, like the resource utilization is better, and Amazon is also passing on the savings when there are multiple tenants who are sharing the workload. And even if you still need to get isolation at the network level, or if you want to pay more and get complete isolation, so those options are available. So if you want to have resource reservation and tight provisioning and all those things, pretty much they are giving you the option. But by default, it is a multi-tenant architecture or a multi-tenant workload system. So which means like Amazon is utilizing the resources and they are passing on the cost benefit to the customer. Second thing is scaling, right? So there is nothing like minimum, maximum and all. You can store whatever amount of data that you want. There is no predefined limit. You can scale as much as you need, and it is horizontal scaling. It's like you keep adding more tables, and more users are connecting to it, more applications are connecting to it. Automatically the table can grow elastically across multiple availability zone. There is no manual intervention. So completely the backend servers can also grow up to thousands and 2000s of more than that. So there are customers who are having thousands of instances for their pretty much heavy workload applications. And the performance, there is no compromise there. You get guaranteed consistent performance. It can be for a small scale application or any terabytes of data application. Still you get single digit millisecond latency, and whatever the partitioning or the security related aspects that you want to do, you can also pretty much do it. So they give you a free hand that is schemaless. You can just go and configure your application. It provides, it gets single digit millisecond at latency. Plus, if there is any increase in demand through horizontal scaling, it can also do partitioning and repartitioning whenever it is needed. Okay, and finally, like there are two other important things: high availability. I said 99.999 for global table, and for the local tables in the same region, it is 99.99. So definitely it has got the option to go and have geo replication configured and across the globe. And in that case, you get 99.39 of availability. And use cases, of course, there is a lot of focus on different customer requirement and applications. So there is a lot of flexibility, right? If the data model is flexible, why not customers will definitely try for their application. And it also doesn't force any developers to follow this is what it should look like, and there is no guaranteed schema, there is no particular data model. The developers has got a free hand, so they can come and connect their application through APIs and SDKs with flexible data model. There is no fixed schema, and each and every data item can contain whatever data type you want. If you want a number, or if you want integer, or if you want some specific string or array or whatever, right? So anything could be stored here. There is no stringent schema restrictions, and it is a key value database. It is a key value document data model where developers can go and select whether they want eventual consistency or strong consistency. See, eventual consistency is eventually it will take some time, there will be some delay, and it will get updated. But if there is application like if you are using it for, let's say, there are some use cases we talked about, right? See, for example, real-time bidding and all, it should not have old data. So it should have strong data consistency. Even you can also achieve it. So it's not that always it will be eventually consistent system. Even at times, if there are some application where we need strong consistency, we can also go and enable that. So hope there are no questions, and let me move on to the pricing, and then we will talk about Redshift, and we'll also see some practical. Okay, so okay, I think Yeah, so these are some interface examples that I've got. So mostly these are the top four activities that people will perform on the DynamoDB. So adding new item, or deleting the existing item, and retrieve the items which are stored in your DynamoDB table. See, DynamoDB table is very much simple in architecture. So it has got a table, within that items, and within that you go and store the key value content in the form of what we call it as attribute. Okay, coming to pricing, there is charges for reading, writing, storing the information into the DynamoDB table, because it is completely database as a service, right? So AWS is not charging anything in direct for server or licensing or database instance. So they are just directly starting the bill with how many writes, reads, and storing the data. So there is a free tier limit available, and there are two capacity models. Okay, the first model is on-demand model, where the billing will be as per the usage or pay per request pricing, and automatic scaling is also there. You don't have to plan, provision, and manage capacity. But if in case your application is very much critical and you want to provision the number of reads, writes per second, and what kind of expectation your application has, then we can go for the provision capacity model. So provision capacity model, whether, I mean, if there is a steady, consistent, predictable performance that you need for your application, then you can go and configure these reads and writes. The provisioning can be done. I mean, when I say provision, the reads and write expectation can be configured, and that way your application will get the same exact consistent performance in a steady and predictable way. And you can also go and forecast and get the capacity requirements to control the cost. But here it is, this option, the on-demand option, is flexible one. So you cannot get guaranteed performance, because on the fly it is automatic scaling and it is increasing. So eventually, like after some time, once the load balances, and then the performance will also get balanced. So there will be small delay when the demand is high, but after some time, like the serverless database will automatically scale, and you will start getting the same amount of performance that you can get from the provisioning option. So there are many different attributes that are used for charging. So data transfer out, of course, is a default charge for any service in Amazon, because like this is a database as a service offering, right? We don't have instances that we manage, and any on-demand backup that you run, it will be charged separately. And then any continuous backup or restoration activity, or if you're exporting and importing data to S3, again, it is a internet bound activities, right? You can also configure these through the private endpoint. Those options are there. If in case you want to configure the export and import through a backend private endpoint or service endpoint to Amazon S3, you can pretty much do it. And you can also get the data captured through the ETL jobs, extract, transform, and load kind of activities, like glue and kinesis can also be used. Primarily it is three factors. Okay, read, write, and storing the data. Those are the three different factor for pricing. But outside of that, there are many other features that are getting billable for you. So with that, I will move on to the other topic, and at the end we will also see the demo on how to create and how to manage. Okay, let me log into the screen before we get into the Redshift. I will go to one of the region. Let me stick with the parent region, US East. Okay, let me go to DynamoDB table. Okay, this is NoSQL and serverless. And here you can just, the very first step is going and creating a table. Unlike your RDS, in RDS, we have to go and start creating a database instance, and then we have to select what the database engine, and then what is the default database. We have to provide a lot of information. So here directly we can go and create the table. If you have any existing content on your S3, you can also import it from there. And even if you have some existing on-premises NoSQL DB content, you can also use Amazon Data Migration Service to migrate your databases to DynamoDB. Right? You can just give it a name, and see, there are two important things that you need to provide. See, in a table, let's say, as I told, there is no schema, but still there are a couple of information that you might have to give. So when you go and create some table in RDS, we just give the number, and then let's say name, and then age, and all those things, right? So there should be couple of columns that has to be given in the table here. So okay, maybe there might be other things like department and date of birth or date of joining and whatever, right? So location and all those stuffs can be there, but there needs to be one partition key. That is where you go and have the primary key of that DynamoDB table. So you can have maybe name as the partition key here. So and then you also need a way to sort it. So sort key is optional, not mandatory, but partition key you have to give it. So you can use age to sort the age, or by the date of birth or date of joining. You can also use a sort key, but sort key is optional. If you want to sort the data through particular column, you can also do it. That's what they have mentioned here. So I can just give something here. I can just say name, and then I will go with the same example. Okay, I can give the string, and age I can give it as a number, let's say, and here it is all case sensitive. Okay, it can accept up to 255 characters, but both the partition key and the sort key are case sensitive. Okay, here I can just give it a thing, and then I will say attendees database. So this is the schema less. Okay, you don't require any data to be any schema to be configured. You can just go and just create a database, and then you just have to provide only the primary key here, and that is called as partition key. So I will create something with the default settings. I will also show some more option. See, by default, as per Amazon standard, they are all creating some options, and pretty much many of them are editable. So if you look at here, so there are certain options you need to be deciding before creation. See, the ones which are not modifiable, you have to decide whether the changes will be needed later or not. So only this one is not editable after creation. Rest all are editable. So which means only the index, the local secondary index cannot be changed. Rest all are changeable, like the read capacity unit, RCU, WCU, the capacity model or the mode, from on demand to provisioned, DynamoDB standard to the other option. So you can pretty much change all these options. Okay, and you can also go and change certain default settings. If you want to have deletion protection or accidental deletion to be turned on, you can also turn it on. And by default, encryption management is taken care by Amazon DB, but if you want to have your own key, you can also go and change it. And so I will just go with this. This is the best practice or default practice that we have got. If you go to the customize option, you can go and customize based on the customer need. For example, if I want the capacity mode to be provisioned, I can also go and change it here. So I will get those two options. So provision option, if I go and provision it, it will give me the option how many minimum amount of capacity unit, maximum capacity unit I want. And based on the customer's traffic pattern, if they are doing a brownfield existing transformation to cloud, maybe they might have been using MongoDB or other tools where they might have already got the metrics, what kind of capacity this particular database is needing. And you can also go and configure that minimum and maximum, and auto scaling can also be turned on. Okay, so that way this is not going to get limited. So when the target utilization reaches a particular thing, it will start doing it. So on demand is based on the demand, it will keep adding. And provision, you are guaranteeing it. And whatever the minimum capacity you are giving, either you read it or write, you don't write it, you still have to pay for the minimum capacity if you're going for provisioned option. But on demand is based on the demand, based on the usage, you are going to pay for it, right? And there is one more option on the top called the standard and standard infrequently accessed. This is for the cost optimization. So now many customers are saying, like DynamoDB table, there are a lot of data that we are storing which we never access or very very rarely accessed. And looks like DynamoDB does not have a bill like S3 storage. S3 storage has got standard and infrequent access category, right? Similarly, they want to have an infrequent access category option for a specific table, where you can also recommend for the table there the data are not frequently accessed. But for your application, if the data is regularly accessed, you can go for the standard choice. So all these are customizable except of the secondary indexing option, which cannot be changed after the table is creation. But rest other options you can go and change it anytime. And I will also show you once the database table is created. And if you have exported something from your on premises, or if you are going to bring some existing databases, I will show you a demo later. I'll share the demo later. We can use database migration service to migrate from MongoDB to DynamoDB or some other third-party database to uh, Amazon native. So it takes couple of seconds to get created. It is now readily available. And if I go and check the content, there are the contents available, the partition key and then the sort key and all those things. And if I want to go and export this or configure a backup as an administrator, you can also go and configure on-demand backup. So here there are two options. One is like the point in time recovery. This is like a snapshot you can take before any changes or major changes to your data. So point in time backup is different. So you can also configure snapshot. And you can also configure, you have to change it. See, if you turn it on, by default it goes for 35 days. And you can also customize it. If in case you don't want to have others, you can just turn it off. And here is where you go and create a backup. So backup is different. Uh, Snapshot is different. Snapshot is for any business application activity. If the business is saying go and take a snapshot to do a quick rollback. But backup is your regular routine data backup, where if you want to restore the complete table, you can just come and do it. And you also have an option to go and schedule the backup on a particular frequency based on the non-business hours or the off-business hours. You can go and use those maintenance window to schedule the backup and get it done. So backups are different from snapshot. Both are supported. And if your applications are global in nature and you want to have multiple replicas created in another region, you can also go and configure the global table option. This is where multi-master and multi-region concepts comes into play for your application, which is global in nature. And if your business application is scattered across different AWS regions, you can also go and configure the replicas here. Of course, monitoring, there are a lot of basic default alarms and metrics that are available. And if you want to get more insight, you can also go and configure it. So here is where you come and understand like what is the number of reads, writes, and what is the number of get items, scanning being done. So it gives you detailed granular metrics, not the same metrics that you see in the other system. So here you get, because we are talking about the get item, put item, and these are the regular tasks that we generally do, right? And if your application has got specific thing, for example, there will be a lot of updates happening or there will be a lot of retrieval happening, you can also go and understand those parameters here on how many get items or how many put items or how many updates are happening on the thing here. This is the write related stuff, and there is a read related stuff here on the top. So they are categorized into read usage and write usage. And you can also measure the latency and performance. And if there are some data that are getting cached, so you might see some wrong data. If you want to go and configure the time to live, you can also go and configure the time to live of your data. So that way the data will be more consistent. And if there are any errors on the activities, it will be clearly captured separately. So DynamoDB table, they have pretty much grouped in a way that the problem management team or the troubleshooting is much simpler compared to any other tool, I would say. So they have got the errors grouped separately, and then they have clearly given you how many transactions are happening, and if there is any issue with the caching or time to live, all those things are pretty much grouped and shown here. You can also go and see the same on the CloudWatch contributor inside the CloudWatch tool directly. And if you want to export what you have configured to a S3 bucket and import it later and as a manual thing, you can also do it. And if you want to continuously stream it to another location through Kinesis, you can also configure it through the Kinesis. And DynamoDB also has got its own streaming API. You can connect any external tool for continuous streaming or export. So permission and additional settings is mainly to fine tune on the different models that we have got. If you want to have consistent performance, you can go and change it to provisioned option. And if you want to enable auto scaling and limit the number of systems, you can also configure auto scaling. And if you want to get immediate performance, you can also go and configure the planned peak events. For example, if there is a weekend activity and you want to have the system to be prepared for that particular activity by having more caching and performance, you can also go and configure this warm throughput option. So that way the caching and the data access latency will also get pretty much better. So time to live, encryption, all these things are available here. So time to live is to have the TTL configured based on your application requirement, and encryption is pretty much standard. It is by default encrypted, but if you want to have the changes done, you can also come and have your own customer managed key, or you can have the AWS managed option. So customer managed option is the third option. If you have your own keys and encryption, you can go for it. So any questions so far on this thing? So here, if I go to the usage, so okay, so these are the things. So get item live count. Let me go and do some actions here. I can edit the capacity, or I can create an item, or I can just go and edit the table. So let me try to create an item, and I will show you. See here, these are the two things that are available by default, right? And if I want to add any additional attribute, I can just go and add any additional attribute with some specific thing. So what were the example that we are talking about here in this thing? Yeah, something like department or age and other things, right? So I can just add a number. So this is like the number to start. I can just say 1. The name can be something like Stan, and then it can be like 41 something, and then create this item. So here I can just okay, so let me go here and let me add some more data. Okay, so I'll just say I want to keep something, and then you can need attribute. So you can add anything, right? That's what. So let's say even it can accept null entry also. Location. If I don't know the location, I can just keep it null. And if I want to have some string, let's say department, let's say IT department. So the interesting thing is I'm adding as many attributes for each and every entry, unlike your RDS, right? So here I'm just going and giving whatever the entries, and then it is going to give me the thing. Okay, and I can also go and scan and understand how many items are there, and then what is the kind of usage and updation. So I can see that there are 2 entries already available here, and I can also go and create a replica. If you want to create something on the secondary region, you can also go and do it. And if I want to edit the capacity, I can come and change the capacity mode anytime. So here is where I come and mention the um, reads and writes and the maximum and the minimum thing. Okay, so this is how you can just create a table, add some items within that, and then within that item you can also go and add some attributes based on your need. Okay, any questions so far on, see, you can also come and check whether those writes were successful, or whether the activities were successful there. So let me
How
come.
can we see the tables? Can-
Yeah, yeah. So you have editor here, and you also have third party. You can also use SQL statements where you can come and check here. So here the data is there. You can also run the query. You can query the table, and if you want to run it and search what are the content here, it's there. It's a kind of what do you call PartyQL is a new option that they've given, but you can also go and scan it here using the native option. It's pretty much the same thing. Okay, like your SQL statements, and it's like they call it as PartyQL, but it is pretty much similar to your SQL querying statement. Let me just say query table. This is select start from attendees table where name is equal to partition key value. No, not this. Where let's say name is equal to, I don't know what I gave, whether it is Stan or Stan, I don't know. Yeah, it returned one. It is giving me the data. So you can also download the report here. So you can also do. I mean, generally people not. Don't, I mean, they will not come and do it here. Instead, they will use application SDKs and APIs. From there, they will use the SQL statements or whatever the particular statements or whatever the application querying languages can also be used. But if you want to see the data from here, I can also just show it here. So that's what it's here, and I'm not sure the second entry I gave Santosh or something. So it can here it is, right? I mean it is case sensitive. Okay, so that's where it is. So you can have any different columns, things. There is no schema. Okay, you can download the content. You can also take the backup. You can also go and see the content here. Okay, and if you want to look at this way, you can also explore it. Pretty much it is taking there only.
ODBC connectivity also we can do with other
Yeah,
external and
yeah, yes,
internal
yes,
applications.
yeah, yeah. You can pretty much do it. So generally, like the people will need this data for ETL activities, right? So they want to extract the data from here, and then they want to transform and load it to whatever the data. So it's not always you have to transform it. You can also directly configure the integration, and you can connect it to OpenSearch or Redshift from DynamoDB. So these are the two major use cases. So either you send it for data warehouse, and from the data warehouse you will use ODBC or JDBC connections from the Redshift. So and even from the OpenSearch you can do a visualization or whatever stuff you want to do. So generally you can export it to S3, and from S3 also you can configure some ETL. I mean, I'll mute your line, there is some background noise. Let's see. So, for your question, Santosh, in general, people will send this data to S3, and from S3 you can connect with any tools you want. Or else, if you want to directly connect it to data warehouse like the OLAP, you can go and store it in Redshift. And from Redshift, you have options for JDBC and ODBC connectivity or any application specific requirement. So, but here the DynamoDB are generally connected directly from the applications, and they can use any third party or SDKs or APIs that are there. And even for visualization, they provide you OpenSearch, or for any advanced level of searching, they also give you this OpenSearch integration. So yeah, I will also show you how to connect it to the Redshift, and from Redshift you can also configure the connectivity for JDBC and ODBC related activities. So here within this particular system, okay, you have some options here. Let's say think no, not additional settings. I'll show you those options in the Redshift in next few minutes. Okay, for here, like it is all pretty much straightforward. Okay, you can just go and get the content here, and if you want to query it, you can go and query it from your particular editor. And there used to be one more editor here only, but I don't know where that went away. Index I cannot, I don't have to add the table, create item, create index. Okay, manage tags. Hmm, okay, so here also it is again taking to the same thing. Here they are giving it. Maybe I think you are expecting something like this, right? To see all the items in that particular table. So earlier they used to have that view option within this console, but they have moved the items alone to a separate screen here. So if I want to view that details, they are giving me under this category. So automatically they are retrieving and providing the items within that, whatever I've created, right? So those entries are here. That's what I'm saying. So you don't have to have the same table, same column, rows. You can have whatever you structure you want, and you can use it. So this is what they are giving you. And if you want to filter by some specific attributes, or if you want to query, you can also query it here. So this is where you don't have to really understand or know any querying language. Here you can just go and say the partition key, let's say what do you call, equal to maybe stan, and then the age equal to something, and then you can run and get the data. So that way you can also easily filter it, or whatever way you want to do it. On the graphical level also you can do it, or if you want to use the particle editor, you can also go and run the query and get the data. So filtering is pretty much available here. You can go and have conditions and add additional filters. So if there is a complex set of information, you have the option to come and search it within the console. But generally, people will connect it from their application using the APIs and SDKs, and they will update it.